All right, so now time to actually start coding and programming the AI for this project. Now we're going to be using the neat module to do this, which means that a lot of the hard work is actually already done for us. And we kind of just have to understand the underlying concepts to make some good decisions on what to feed this neat algorithm and kind of the configurations to set this up. Now I've already discussed how this neat algorithm works in terms of the Flappy Bird project. So please, if you haven't watched that video already, go watch it. Now this video, it's not actually a part of this series. It was kind of the project outline for this. I'll leave a card in the top right hand corner of the screen, which actually I guess is going to be over there, as well as a link in the description to that video. Now it's only a 10-minute video, but it explains exactly how this works, and I highly recommend you watch that because I'm not going to be re-explaining any of the stuff I said in there. Now here in front of me is the neat documentation. This will be in the link in the description every video, and essentially if you're lost on anything or you feel I didn't explain something well enough, please feel free to come here, read through the documentation. There's everything that you need. This is how I learned to use this, by just reading this myself, so I'm sure that you guys can figure it out if you need to as well on here. Now, last thing, if you're still lost with neat and you want some more stuff to try to understand this, I highly recommend that you read this paper. This is the original neat paper. It's actually referenced in this documentation here and explains exactly how this algorithm works. So please go ahead and read this. It's only 6 pages long. It's fairly technical, but I think you guys can get through it. I read it 2 or 3 times, and after that, I feel like I understand the neat module much, much better. So again, that link will be in the description down below. Okay, so now that we've done that, let's talk about what we actually need to do here. So the way that neat works on a very basic level is it evolves a neural network. So maybe we start with a really basic neural network. So we have 3 input neurons and we have 1 output neuron, and maybe these are all connected. Well, what neat actually does is it will change the values of these connections, so the weights, and then it will randomly add other nodes. So maybe we add a node up here that's connected like this, and remove and add connections. Now, the reason it does this is to try to find a topology or kind of an architecture for the neural network that works best for the problem we're solving. So it starts very simple, and then it gets more and more complex only as it needs to. Now, if it doesn't need to get more complex, it won't do that. And that's actually a very good thing in our case, because that means that if we could have a very basic neural network solve the problem, that's favorable. And neat will allow us to do that by favoring kind of smaller architectures if they're performing better than a more complex one. Now, I don't want to go in too depth about how it kind of adds nodes and all of that, and the mutation and all of that jazz. But just understand that we start with a very basic neural network, and as we need to, we will add complexity to that network in terms of other nodes, other connections, more neurons, different layers, and that's something that we don't actually do, but the algorithm will do by itself. Okay, so now that we kind of have a basic understanding of how that works, let's now talk about the things that we actually need to give the neat module or the neat algorithm so that it can figure this stuff out for us. Now, the first thing and the most important thing that we need to do is discuss what the inputs are going to be to our neural network. Now, again, this is just neural networks being evolved using a genetic algorithm. And I've talked about how this worked in the other video, but essentially, if we don't have these inputs right, we can never be sure that we're going to get a good neural network or a good kind of AI that's working. If it doesn't have the correct information, how can it possibly figure out, how to jump through those pipes correctly? So let's talk about what information we should actually be giving to the neural network. Now, in my case, the information that we're going to be using here is just enough that's not too much information, but that should hopefully let the network kind of figure out some patterns. Now, I'm going to start by giving the network the position of the bird. Now, since the bird doesn't move along the x-axis, all we need to do is give it the y position, because that's the only direction it's going to be able to move in. So we'll give it bird y, and then what I'm going to do is simply give it the distance between the bird and the next upcoming top pipe, as well as the distance between the bird and the next coming bottom pipe. So I'm just going to put top pipe here and bottom pipe so that we kind of have an idea of what this is. Now, some of you may argue that we don't need both the top pipe and the bottom pipe, and you may be correct. I would encourage you, when we actually set this up, to only use maybe 2 of these inputs and see if you can get it to work like that. Now, the reason I'm using both of these is because I think this speeds up the process of the network figuring this stuff out, because it doesn't need to determine the gap distance in between the pipes if we only gave it one input of the top pipe or just the bottom pipe. All right, the next thing we need to talk about is the output of our neural network. Now, the output here is pretty simple. It's either we jump or we don't jump. That's the only control we actually have for our game. And whenever programming an AI for a game, we kind of think of the output as what button we should press or what the program should actually do, what the character should do. So maybe, you know, if we're playing like Snake and we're like moving all around, then what we might have is, you know, move up, move right, move down, and move left, which means we need 4 output neurons to represent all of these decisions. Now, since all we're going to be doing here is saying, you know, click space or don't click space to jump, then all we need is 1 neuron, and this is just going to say, I guess I'll write it in red so that it's consistent here, jump or do not jump. So these are the first things you always need to think about when you're programming an AI. What are the inputs going to be and what are the outputs going to be? All right, so now that we have that, we can talk about the next important part, which is the activation function. Now, this isn't crazy important, but it does make a difference on how you're going to evaluate this output neuron. So in this case, we're just going to pick the activation function for the output neuron, and we're actually going to let Neat pick the activation function for any hidden layers or hidden neurons that we have. But in this case, I'm going to use an activation function called tan h. Now, this is actually the hyperbolic tangent function, and it looks something like this. I'll draw it out really briefly here. So I'm going to say that this line here is 1, and this line here is -1. And what this looks like, this is going to be a crude drawing, so please excuse me, is something like this, where essentially the larger positive a number, the closer to 1 it's going to be, and the larger negative a number, the closer to -1 it's going to be. Now that just allows us to squish whatever value we get from this output neuron to be in between -1 or 1. And this way we can evaluate what, you know, the value of this is, and then we're going to be able to tell whether we jump or not jump. Now, there's other popular activation functions like sigmoid and all of that, and we could have used a sigmoid function for this, but I like tanh, and what we're going to do with this tanh function is, since it squishes our values between -1 and 1, we're going to check if the value is greater than 0.5, and if it is, we're going to jump, otherwise we're not going to jump. Now, we could have done the same thing where we check if it's greater than 0, but 0.5 just works better for this, and we can talk about that a little bit later. All right, the next thing that we need to give our NEAT algorithm, and this is specific now to this NEAT module and genetic algorithms, is the population size. Now, this is a pretty arbitrary value, and it doesn't matter a ton. In fact, you can actually play with this value, and you'll probably still get the same result. But in this case, we're going to start with a population of 100 birds. Now, essentially, the population is how many birds we're going to have running each generation. So essentially, the way things work is we start with generation 0, so we have gen 0. We have 100 birds in this case, which are just going to be random neural networks, so random neural networks controlling 100 birds. And then what we're going to do is we're going to test all these birds. We're going to take the best of these birds, breed them, mutate them, and create another 100 birds in the next generation, which is generation 1. And then hopefully these birds, since they came from the best of the previous generation, will be a little bit better. And we keep going and going and going and going until eventually we get some perfect birds. Now, this number essentially just means, you know, how many birds are we running each generation? How many are actually trying? For really complex problems, you might need to do, you know, like thousands of birds running at once. But for this Flappy Bird game, you know, we could probably even bring this down to a number like 10 and still be able to have a high degree of success in coming up with a solution. Essentially, the more birds you have, or the larger the population size, the more variance you're going to get and the more random stuff that's going to happen. So we have a higher chance of, you know, generating a bird with a new connection or a new node or something like that. And kind of the structure will just get a little bit more complex for some of our networks. Since this is Flappy Bird, we don't need to do anything too crazy. So we'll just set this as 100. And again, you guys can mess with this. I've done it with 50 and it worked fine, but 100 is just what we're going to go with. All right, so the next part and the most important part to talk about now is the fitness function. Now, the fitness function is by far the most important part of the NEAT algorithm. Now, obviously, these inputs and these outputs matter a lot because these are what the information is and what we're actually going to do. But this fitness function is how we're actually going to grow and how these birds are going to get better. Now, we'll talk about the fitness function in the next video specifically and how we use that. But it's something to keep in mind that we need a way to evaluate how good our birds are, because the way this NEAT module works and this algorithm works is we take the best birds from one population, we breed them and we mutate them, and we keep doing that. Now, if we're not actually getting the real best birds, or we're scoring on some kind of metric that doesn't make sense for the best bird, then obviously we're just going to have a trash AI. So we need to make sure that however we score these birds and get, figure out which ones are better makes sense. So how do we do that? Well, for Flappy Bird, it's actually pretty straightforward. There's a few different ways you might think about doing this, but what I do is literally just say, I'll draw a bird here. This will be my bird, the circle. Whatever bird makes it furthest in the level did the best. So every kind of frame that the bird moves forward, like every X position it goes forward, we're going to give it another point. And the birds that get the furthest in the level, so, bird over here is going to be a lot better than bird over here in terms of fitness, because he made it further, or they made it further in the level. So that's the way I'm scoring fitness. However far you get is what we'll do, but we'll also talk about some tweaks that we can do on fitness and how we can influence birds to make it further in the level by adding some things later. All right, so let's say fitness function, we'll just say like distance, so like how far it goes. And I guess I'm writing in black now, but that's all right. The last thing to talk about here now is the max generations we want to run for. So at some point, after we've ran for thousands of generations, if we still don't have an AI that works really well, we're probably just going to give up and try again, because maybe we got unlucky. Maybe when we added connections, when we did things, it just didn't work out in our favor. So what we're going to do here is set a max generation. In this case, I set a max generation of 30, which means that if I make it past 30 generations and we still don't have a perfect bird, then we're kind of going to cut this program. We're going to try again because 30 is just too far for me. So anyways, that is kind of the information we need. We've talked about that now. So let's just start programming, and the more stuff that we program, the more stuff I'm going to have to explain anyways. So let's get on with it. All right, so the configuration file. Now, this is a very important thing that we need whenever we're creating a neat project or using the neat module. And this essentially is kind of setting up all of the variables and just parameters for this algorithm to run. And a lot of the things that I discussed previously, like in the last few minutes, we're going to set in this configuration file. So if you don't want to type this out from scratch, which I don't recommend you do, just click the link in the description to download this. It'll just download a text file, and then make sure you drag that text file into the same directory as your main Python script, because we're going to use it probably in the next video when we actually set things up. So let's start talking about some of the stuff in this configuration file and just setting some values. I actually already have it set to all the stuff that we need. We'll talk about what it does and why I've set it to that. So the first thing here to talk about is in this neat section, and this is fitness criterion. Now this is simply a function we can either choose from min, max, or mean, and this determines how we get rid of the worst birds, or actually like what function we use to determine the best birds. So obviously we calculate a fitness for all of our birds, and we do that from actually this main script, which we'll do later. But now when we need to remove birds or add birds, we need to know whether we're taking birds with the highest fitness or the lowest fitness. Now I know it's weird, like why would you get rid of birds with the lowest fitness, but sometimes you might want to do that. So in that case, you would change this to min, but in this case, we'll just put max, okay? Which means we'll take the birds that are the best, we'll breed those, and we'll keep those ones, and we'll get rid of the ones with the lowest fitness. All right, now fitness threshold, pretty straightforward. This simply means what number do we actually need to reach? So what fitness level do we want to get before we terminate the program? So in this case, I'm saying, if we have a bird that reaches a fitness score of 100, then I'm going to say we're good enough. This bird is likely going to go on forever. He's going to be very good. We don't need to do any more generations after that. And that's exactly what this does. So whenever we reach a population and there's a member in that population that has a fitness higher than or equal to this value, we will stop running the program. That's what this does. All right, next, population size, pretty straightforward. This is 50. That's what I'm setting. Did I say 100 before? You know what, let's do it as 100. But again, you can change that value to 50 or whatever you want. Reset on extinction essentially means that what neat actually does is it separates the different kind of architectures of all of our population into what we call species. So birds that have, 2 or 3 hidden layers or some weird nodes in there will be one species, and birds that just have that standard, 3 nodes, 1 output neuron will be its own species. So it's saying, as if we have a species go extinct, do we reset a value? In this case, it's just false. We don't really have to talk about that too much, but you can look that up in the documentation here. I'll actually show you if you don't understand how something works. If you go to reset on extinction, if this evaluates a true, when all species simultaneously become extinct due to stagnation, a new random population will be created. So that's what that does. I guess I kind of misexplained that, but anyways, all the stuff's in the documentation here. Anyways, next thing, so default genome. All right, so this is very important. So in NEAT, we call all of our population members, so in this case birds, genomes. And genomes have a few different properties to them. They have what are called nodes and what are called genes. Now nodes are the input nodes and the output nodes, and genes are actually the connections between those nodes. So this is setting up the default starting genome. So each member in our population will start with these specific values. So this is very important that we tweak this correctly. So this is where we're setting the activation function. So activation default is tan-h. Activation mutate rate means if you wanted to change the activation function to be something else randomly, you could change this value to be 0.1 would be, there's a 10% chance that whenever we create a new population member, they will get a different random activation function. I don't want to do that, so I'm going to leave this as 0. Activation options are just the options that we can choose from as the activation functions. So what this activation mutate rate will actually pick from. Now aggregation default, I'm not going to talk about what this stuff does. You can look at that if you want. Now this is kind of the initial connections that we have and how likely they are to change. Now when we say bias max value and bias min value, this means that for that bias that we have, what is the maximum value that we can pick and what is the minimum value that we can pick? Because we're randomly going to set up our first neural networks. So they have random biases and random weights. So let's just kind of define that, we don't want a bias that's 10 million. So we're going to squish it in between 30 and -30. Now mutate power and mutate rate and replace rate is how likely these things are to change when we mutate and breed and create a new population of birds. Again, just leave these like this. You can mess with them if you want, but these are the numbers that work best. All right, so genome compatibility options, compatibility disjoint coefficient. Okay, I'm not going to talk about those because I honestly don't even really know what those are. I've kind of just left them. The default values from another example I stole this configuration file from. All right, so these ones are pretty straightforward. Connection add probability and connection delete probability is how likely we are to add a new connection or remove a new connection. And again, this is at 50% right now. So if you wanted to not have it add as likely or remove as likely, you could decrease this number, maybe put it at 0.2 or something, but these are the values we're going to use. All right, enabled default and enabled mutate rate. So enabled default essentially means that we can have connections that sometimes are enabled or not enabled. Now, this is kind of a weird thing with a neural network where these connections have another parameter on them where they're either, active or not active. That's what this means. By default, we're going to have all our connections be active, and to actually deactivate a connection, there's about a 1% chance that's going to happen. That's what this means. All right, feed forward equals true. That's straightforward. We're using a feed forward neural network. Initial connection equals full means we're going to have fully connected layers to start. Node add probability and node delete probability, 0.2. So same thing, 20% chance of adding a new node or removing a new node. Again, these will be neurons if we're talking in other terms. Number of hidden. Okay, so this one is probably the most important. This is actually setting the default input neurons, or amount of input neurons and amount of output neurons. So in this case, we're going to have 3 input neurons like we've talked about, 1 output neuron, and no hidden neurons to start. We could, change this to 1, and then we would start with a more complex network. But in this case, we're going to start as simple as possible, which is 3 input and 1 output. All right, I'm not going to talk about what all this does. You guys can look that in the documentation if you want. Same thing here. Again, this is just kind of a few tweaks here on how the weights work. This is kind of similar to the biases in terms of changing them and all of that. I've just left these default from another example I took this file from. Compatibility threshold, we don't need to know that. Species fitness function, that's kind of similar thing to above where we're going to take the max fitness from those species. So max stagnation, I believe, is how many generations we go without increasing fitness. So if we reach a point where we have 20 generations go by and our fitness doesn't increase at all, like the max fitness for our group of birds doesn't increase, then we're going to eliminate that species. And species, again, are just, they're kind of like grouped based on their architecture. So anyways, that's what that does. And then this here is, we don't really need to discuss this, survival threshold. And they're not super important, but again, you guys can go in here and read through them if you want to know what they actually do. All right, so with that being said, this has been a bit of a longer video. We haven't done any coding, but I needed to explain kind of how all this stuff works and what it is. So when we go into the next video, we're not super lost. Again, this is difficult to explain. There's a lot of stuff, and I kind of need to be selective on what I'm teaching and what I'm not teaching. And some stuff you're just gonna have to learn on your own. That's the way that it works. But as we experiment and go through this in the next videos and actually write the code, which we'll do in the next 2 videos, I guess, you guys should start to understand this and it should start to make sense. But always feel free to, mess with stuff. If you don't understand something, ask questions, join the Discord server and all of that. With that being said, I'll see you guys in the next video.